All right, we're going to take some time and go through the solutions to the Chapter 5 practice problems. The first practice problem is number 3 on page 135, Airshow. It says to keep the spectators out of the line of flight at an airshow, the ushers arranged the show's seats in the shape of an inverted triangle. Kevin, who loves airplanes, arrived very early and was seated in the front row, which contained one seat. The second row contained 3 seats, and those filled very quickly. The third row contained 5 seats, which were given to the next 5 people who came. The next row contained 7 seats. This seating pattern continued all the way to the last row containing 2 more seats than the previous row. All 20 rows were filled. How many people attended the air show? One thing we want to note before we move on to the next slide where we explore the solution is that with each row, the next odd number in ascending order fills up that row. So row 1 was 1, row 2 was 3, row 3 was 5, row 4 is 7, and so on. So we'll go up then to 9, 11, 13, and so on. So whenever we're trying to find a solution, and we do so by patterns, we need to enumerate as much data as we can until a pattern emerges. So we're looking at the rows and the number of seats that are filled in each row, but because we want to find the total number that are filled with all 20 rows, we need to have a third column where we're totaling up our amount. So in row 1, we have 1 person seated there for 1 total person seated all together. In row 2, we have 3 seated. Total will be 4 people seated. In row 3, we have 5 people seated in that row, then altogether is 9. Row 4, there's 7 people seated, altogether that's 16. And as we keep going with row 5, row 6, row 7, as we look at the total column, we notice that these are all perfect squares, and they're exactly the square of the row that we are looking at. And they're also the total number of the people seated up through that row. So seated up through row 7 is 49 people, meaning that if we want to find those that fill all 20 rows all together, we would do 20 squared, and we would get 400 total people are there at the air show. Moving on to number 6, beach ball. It reads, Kazuko, had no idea that was a name, has a beach ball. It is colored with 6 vertical sections in order, white, orange, yellow, blue, red, and green. She spins the beach ball and she notices that the colors whirl by very fast. If the first color to go by is white and the ball spins around so that 500 colors go by, what is the 500th color? So similar to the last one, what I did is I enumerated as much data as I could in an organized fashion so that I could look for a pattern to emerge. The way that I did so was I labeled my 6 different colors with their first letter on the left side. So I have white, orange, yellow, blue, red, green. And then I have the number of spin that it would occur. So we have white occurring on spin 1, then orange is the second color to spin around, then yellow is the third, blue is the fourth, red is the fifth, green is the sixth, and then you start back over. White will be on the 7th, orange will be on the 8th, yellow will be on the 9th, blue will be on the 10th, red will be on the 11th, green will be on the 12th. And I kept going with this pattern. And I mean, there really was no rhyme or reason, but I just decided to stop at 42 and take a break and look at the data to see if I could see any unique pattern that would pertain to any one of these colors. Because if I could figure out a pattern that existed for one of these colors, I could, because there are 6 there total, I could look to see if whatever number's close enough to 500, that would be divisible by either 2, 3, 4, 5, 6, and know the color that would happen on a digit near 500. Well, I got lucky because I noticed that for green, green always shows up on a digit that is a multiple of 6. So I wanted to find a multiple of 6 then that is near 500, but lower than it. And I realized that 498 is the closest multiple of 6. Now you could use trial and error to find that out, or you can use divisibility rules, which is what I did. A number is divisible by 6 if it is divisible by both 2 and 3. 2 is easy. It has to be even. 3, you add up the digits, and if the sum of the digits is divisible by 3, then that overall number is. So 4 plus 9 plus 18 is 21. 21 is divisible by 3, so 498 is. If it's divisible by 2 and 3, it's divisible by 6. That means that green appears on the 498th spin. White would be on the 499th, because the pattern would start over again, orange would appear on the 500 spin. Okay, the last practice problem is number 10, and it reads as follows. It says, this sequence is formed with pairs of numbers. Fill in the missing two pairs. So before you go on to that next slide, you want to just take some time, look at this again, and you probably have already taken that time, but if you haven't, look at these ordered pairs and see if you can find the pattern that emerges so you can fill in those two blanks. So what you noticed, the X pattern is pretty obvious that the X's are increasing by sevens, then fives, sevens, then fives, and that pattern continues to alternate. What remains consistent with the Y's but is unique is that the Y's emerge as a product of your two X's. So 1 times 4 is 4, 2 times 1 is 2, 2 times 6 is 12, and so forth. So we have to use the pattern of +7 +5 to find our X value first, and then we can determine the Y value. So we did +5 to get from 33 to 38. So we add +7, and that gives us 45. 4 times 5 is 20, and that is how we get the solution for the first order pair. Then we know that we need to add 5 to 45 to get 50, and 5 times 0, or 5 times 0 is 0 to give us our Y coordinate. And that is the solutions to the practice problems.